Hello everyone, welcome once again to Calculus and Analytics. Today we continue our discussion limits and its application. Use the position function s of t is equal to negative 16t squared plus 750, which gives the height in feet of an object that has fallen for t seconds from a height of 750 feet. The velocity at the time t is equal to a seconds is given by the following. Limit as t approaches a of s of a minus s of t all over a minus t. If a worker drops a wrench from a height of 750 feet, how fast will the wrench be falling after 3 seconds? Now we know, or we given, s of t is equal to negative 16t squared plus 750. V of t is given as limit as t approaches a, s of a minus s of t over a minus t. We want to find how fast the wrench is falling after 3 seconds. So that is the velocity at 3 seconds. So that's a V of 3. That will be equal to the limit as t approaches 3 of s of 3 minus s of t over 3 minus t. That will be equal to the limit as t approaches 3 of negative 16. Plugging in the 3 for a, that's negative 16 times 3 squared plus 750 minus negative 16 times t squared plus 750 all over 3 minus t. Now if we evaluate the numerator, the negative of negative 16t squared becomes a positive 16t squared. The rest of the numbers be minus 144. So that's a limit as t approaches 3 of 16t squared minus 144 over 3 minus t. We can factor out the 16 from the numerator to have limit as t approaches 3 of 16 parentheses t squared minus 9 over 3 minus t, and we know that t squared minus 9, that's the difference of squares. So we have the limit t approaches 3 of 16 t minus 3 times t plus 3 all over, we know 3 minus t can be rewritten as negative parentheses t minus 3. Okay, now we notice that we can cancel out a t minus 3 and the numerator, t minus 3 in the denominator. And so we have the limit as t approaches 3 of negative 16 parentheses t plus 3. Now we can plug in. Now we reach a stage where we can plug in the 3 for t because we do not have a denominator issue anymore. So that would be negative 16 times 9. That gives you negative that would be, no, negative 16 times 3 plus 3, which is 6. Negative 16 times 6, which gives you negative 96. And that is our answer. And that should be in feet per second. Feet per second. Because we're falling in feet and the time is in seconds. Okay, let's look at another application of the things that we did. Our limit laws. So the next question is limit. We want to find the limit as x approaches 0 of sine of 4x over x. Now previously we evaluated the sine of theta over theta, and so the sine of 4x over x, we want both the numerator and the denominator, the arguments there to look alike. So if there's a 4x in the numerator, we want to have a 4x in the denominator. So we have to do some algebra right here to make our expression look like something with sine of theta over theta, because we have found what the limit as x approaches 0 of sine of theta over theta is equal to. So what we might like to do is multiply the denominator by 4 to get a 4x in the denominator. And so we also have to multiply the numerator by 4 But because the 4x is an argument of the sine, we cannot just write 4 times 4 is 16x. We would have to write it as 4 times sine of 4x, which is what we do in our next step. Limit as x approaches 0, 4 times sine of 4x over 4x. Now, knowing the law of limits, that has to do with multiplying the limit of c of f of x, where c was a constant, we can pull the constant out. So we can pull the constant out in front of the limit, and so that becomes equal to 4 times the limit as x approaches 0 of sine of 4x over x. Now notice we have something looking like the expression that we're looking for, sine of theta over theta, or a sine of an argument over the exact thing that looks like the argument that was in the sine. And we know that the sine of some argument over something that looks exactly like the argument, that looks like a sine of theta over theta, the limit as x approaches 0, that limit will be 1. So that's going to be 4 times 1. So our final answer is equal to 4. That's the end of it for today. Thank you so very much for watching. Please subscribe. Have a great day. See you next lesson.